Audio Jungle. Audio Jungle.
Hello everyone. So myself Narendra Singh Maurya, and here we are going to solve GATE 2019 jet propulsion problem, right? And here we have problem number 10 first. So the propulsive efficiency of ramjet engine, okay, is lower than that of a low bypass turbofan engine operating under the same condition. Okay, one point here it is given, and producing the same thrust. All right, this is the noted point. Primarily because the ramjet engine option 1 A is given has larger kinetic energy lost in exhaust jet. Option B has lower thrust power. Option C is not self-starting. Option D uh, has higher thrust to weight ratio. All right. So we'll go one by one for all the options, and we'll find which one is correct. All right. First of all, we'll write given detail for this. They have mentioned same condition. That means it is related to atmospheric condition, pressure, temperature, etc. Okay, related to atmospheric condition. Second point they have mentioned properly, same thrust. 2 points they have given. Okay, so to understand the propulsive efficiency of the ramjet engine, we need to go through this efficiency chart basically. So here we have a segments of the power or energy for the engine. All right. So like what is the heat input, or what is the heat power or power input, what is the power output. Okay, so that we can find what is the efficiency. So here basically this is the, you just say this is the, okay, box A, and this is the box B, and this is what box C. All right. And now, so if you go through this box A and B, it will relate thermal efficiency. Okay. Box B and C, it will relate propulsive efficiency. Thermal efficiency will be denoted by eta Th. Propulsive efficiency will be denoted by eta P. All right. Now, if you want to write thermal efficiency, so thermal efficiency is equal to output by input. Okay. You know, efficiency formula is output by input. So here output will be B for the thermal efficiency, and input will be A. Or you can also write this like, okay, one more numbering I just want to mention here. Okay, just wait. So now I will write, this is what P, and this is what Q. Okay, so now this also you can write output, which is nothing but B, divided by input. Input is nothing but output plus loss. What is the output? B, plus what is the loss? P. All right, that also you can write, because input is what? Output by input. Okay, this is nothing but output, and this is nothing but input. So for thermal efficiency, I have written B by A means output by input. Output divided by input. Input also you can write output plus loss. So this P is nothing but loss, which is called heat loss. Similarly, you can write propulsive efficiency, which is nothing but output divided by input, C by B. Or you can write output divided by input. Input means output plus loss. What is the output? C plus loss. What is the loss? Q. Hope you understood. So this for this output is nothing but here we have a thrust power. For the propulsive efficiency, output is nothing but thrust power, and input is nothing but engine input power, which is called propulsive power. All right. Anyway, and loss, it is called unutilized kinetic energy, and obviously this loss will be in nozzle. Okay, this loss will be kinetic energy loss will be in nozzle. All right. Anyway, I can write here this loss will be in nozzle, because we are talking about kinetic energy. All right, so now I will write the full formula. So thrust power, it is nothing but power which is called force into velocity. Okay, what is the force? It is thrust. What is the velocity? It is the aircraft velocity, V infinity, or you can write VI or sometimes CI, that is the aircraft speed. Okay, that's the formula. Now we'll write, so based on this, because we are talking about the propulsive efficiency, so propulsive efficiency is nothing but eta P, which is divided CB, C divided by B, or you can write C divided by C plus Q, which is nothing but loss. What is the C? It is nothing but thrust power. This is the propulsive efficiency, thrust power divided by thrust power divided by thrust power plus loss, which is nothing but output divided by input. And input you can write output plus loss. Yes or no? That very basic, you know that. So here also I can write eta P is equal to thrust power, which is nothing but force into velocity, or you can say thrust into velocity divided by again thrust into velocity plus. What is the loss here? Check. What is the loss? It is unutilized kinetic energy. Okay. We can write unutilized kinetic energy. Okay. In nozzle. Yes or no? That's the formula. Okay. So now we'll check. This is the a formula for the eta P. If you want to write in terms full place formula, so it is eta P thrust, so that you can remember easily, into velocity of aircraft. That will be the thrust power. Okay, thrust into velocity of aircraft divided by again thrust into velocity. Here I will write thrust into velocity only, plus unutilized kinetic energy. What is the unutilized kinetic energy? Check. 1 by 2 m dot VE minus V infinity square. No? 1 by 2 m dot into change in velocity square, you can write. What is the change in velocity? That is V minus V infinity. Exit velocity minus aircraft velocity square. So this is a change in unutilized kinetic energy, you can say. Okay, so here I hope it is now very clear to all this formula. No? Thrust into velocity divided by thrust into velocity divided by 1 by 2 m dot VE minus V infinity square eta P. All right. Anyway, now we will find the correct answer here. Check. The question is, has, because they are talking about like the propulsive efficiency of ramjet engine is lower. So we'll check the segment. If check the formula, eta P is what? Lower. When it will be lower, you just find out. When it will be lower, this is thrust is constant. They have said thrust is constant. They have said, and thrust is constant. In fact, they said same conditions in that atmospheric condition as well as flow condition, that also will be included. I mean, velocity will also be constant because they have said same condition. Okay. Otherwise, you can say thrust into velocity, both in numerator and denominator it is given and it is constant. You just say like that. Also better. Hmm? Now you tell me, if this eta p is what decreasing, then what is the reason of the increment? That reason is what? This unutilized kinetic energy. Yes or no? Because thrust is constant. In fact, velocity will also be constant because they have set same condition. So now from here you can get the correct answer, because that's the reason I have explained propulsive efficiency first, because directly if I will say this is correct answer, so you may not able to understand. So that's the reason I have shown you, and in that way you can understand, okay, what is thermal efficiency, that formula also you can remember. What is the propulsive efficiency, that formula also you can remember. Okay. Anyway, so first option they have given has larger kinetic energy lost in exhaust jet, means they are talking about the unutilized kinetic energy. So uh, it is the unutilized, it means it is the loss. So has larger kinetic energy lost in exhaust jet. If this value will be increasing, obviously larger loss will be there. It means what? It means this second value, this value will be increasing because this is the larger loss. If this value is what increasing, so automatically eta p will be decreasing. Hope you understood this. So this is the correct answer. So what is your answer here? I must say answer is nothing but option. Has lower thrust power? No, lower thrust power means what? Thrust into velocity. So if thrust into velocity, if this thrust power is what decreasing lower, it means numerator and denominator in both cases it is suppose decreasing. Huh? So that eta p value will not be changed because in numerator and denominator both places thrust power is given. Is not self-starting. Yes, ramjet engine is not a self-starting. That is correct, but that is not a reason for lowering the propulsive efficiency of ramjet. Okay. Has higher thrust to weight ratio? No, that ramjet is not higher thrust to weight ratio. In fact, turbofan is a higher thrust to weight ratio. Heavy weight of turbofan engine is there. Hmm? So what is correct answer? Option is correct. All right. I hope you understood this. Next. This is problem number 11, right? While flying at Mach 2.0 at 11 kilometer altitude and producing the same thrust, okay? You just say, this is the sea level. Hmm? From the sea level, aircraft is what? Flying, okay? 11 kilometer altitude, this aircraft is what? Flying. Okay, with what Mach number? Mach number is nothing but M infinity, which is 2.0, means supersonic speed. 11 kilometer, okay? Producing the same thrust, what is the correct order from the lowest thrust specific fuel consumption, TSFC, to the highest? All right, they have given engine, turbofan, ramjet, turbojet, turbofan, turbojet, ramjet, means overall three aircraft based engine based aircraft they have given. One aircraft having turbofan engine, one aircraft having ramjet engine, one aircraft having turbojet engine, and they are comparing all three, which one will have a lowest specific fuel consumption, which one will have a highest specific fuel consumption. And obviously all are the jet engine, hence they have given TSFC, thrust specific fuel consumption. If it is a propeller powered aircraft, then definitely they will be given a PSFC, power specific fuel consumption. But here all the engines are jet engine, not propeller powered engine. Yes or no? So anyway, so it is flying at 11 kilometer, okay, and it is producing same thrust given. What is the condition they have said? They said same thrust. All the engines they have said same thrust. Okay. And for the all three aircraft, engine based aircraft having the same altitude, so all the pressure, atmospheric pressure constant, temperature constant, so all the atmospheric condition it is now constant for all three engine based aircraft. Yes or no? All three engine based aircraft will have the same atmospheric condition. Now we'll talk about TSFC. Okay. So what is the TSFC? Thrust specific consumption. Yes or no? So what is the TSFC? So and it is denoted by, generally it is like SFC only. If you write SFC, also correct, SFC. So what is the SFC? So amount of fuel burned in combustion chamber, M dot F, okay, divided by produced thrust, or just write thrust. Fuel flow rate divided by thrust. So generally SFC, just like for our bike, car, and all, there is the mileage. Na? Like this, for 1 liter of the petrol, like up to what distance that bike or car will run. Okay, I mean in 1 liter of amount of the petrol, how distance you can, how much distance you can cover. That is the mileage for your car and bike. Similarly, for the aircraft. Okay, so here, because it is flying because of the thrust, so your concentration, like, okay, this much amount of the fuel, if we are burning in combustion chamber, then this much amount of the thrust will get after burning of the fuel in combustion chamber. This much amount of the thrust will get after burning this much amount of the fuel called SFC. Hope you understood in very simple language. SFC, specific fuel consumption, is nothing but like for the X amount of the thrust need to produce, okay, then what amount of the uh, fuel you have to burn in combustion chamber. So that calculation you will do with the help of this parameters called thrust specific fuel consumption. You are talking about thrust, hence it is thrust specific fuel consumption. Otherwise, if it is propeller powered aircraft, then you must say PSFC, which is called power specific fuel consumption. And that time you will talk like, okay, this much amount of the fuel, if we are burning in combustion chamber, then this much amount of the power will be produced. Hope you understood. SFC, right? Okay. Now they have given three engines. Three engines they have given: turbofan, ramjet, turbojet, and turbofan. All right. So check. Now you have see, this is what turbojet engine. Generally here, this is the formula you need to remember. I will show the condition for the. This is the turbojet. Yes or no? Turbojet. Here we have this is what turbofan. This is what turbofan. Check, we have this fan, and next is, this is what ramjet. Yes or no? Ramjet. So for all three engine they have said thrust is constant. Okay, they clearly they have mentioned for the same thrust. So now your SFC, definitely SFC, because as per your formula SFC is nothing but m dot f divided by thrust. Okay, thrust. And here thrust is what? Constant for all. Thrust is constant for all. Constant for all. It is clearly mentioned in problem. All right. Anyway, they have said same like um, altitude. So all the atmospheric condition must be same. Now, if you talk about the SFC, so SFC will be depending on the what amount of the fuel you are burning to get the same amount of thrust. What amount of the fuel you are burning to get the same amount of thrust, because for all the engines they have said producing the same thrust. So here now your main concentration will be fuel. Like, so where you are burning more fuel, that will give more SFC. Where you are burning less fuel, that will give less SFC. And that's the question only they are asking. Write the SFC from lower to highest. Now, in turbojet and in ramjet, there is no cold nozzle. There is no cold air. See, this is the cold air because this is the cold nozzle. Both side, huh? Because this is the fan. So this fan will like uh, few parts of the air will go through the core. This is what core. This is the hot, uh, basically nozzle. This is the hot nozzle. Yes or no? And here, this is the cold nozzle. This is the cold nozzle. Yes or no? So here you are getting thrust because of the cold nozzle as well as hot nozzle. So where you are burning fuel in combustion chamber, here in combustion chamber you are burning fuel. Yes or no? So in fact, in turbofan, I think this point is very clear to you. To get same amount of thrust in turbofan, if you burn less amount of the fuel, also it's okay. Why? Because whatever the thrust you will get, it you will get thrust because of the cold nozzle as well as hot nozzle. So if you are getting less thrust from the hot nozzle because you are burning less amount of the fuel, then it's still okay. Why? Because you are getting thrust from the cold nozzle also. All right. So means if all three engine, if you compare, then in case of the all three turbofan engine will have a less SFC. Why? Because you are burning less amount of the fuel. Less amount of the fuel you are burning. Why? Because in cold nozzle you are getting thrust, and in obviously in cold nozzle you are not going to burn any fuel, any amount of the fuel. That's the reason it is called cold nozzle. Okay, simple fresh air it is coming, and it is entering and exiting fresh air. No mixing of the fuel, no combustion occurs in cool nozzle. Hence it is called cold nozzle, right? So even though in turbofan you are not burning fuel in cool nozzle and you are burning less amount of the fuel in hot nozzle or in core also, you will get the same thrust. So where you are burning less amount of fuel, first is turbofan. So we'll find where is the turbofan, okay? Because they are talking about the TSFC from lowest. So turbofan and turbofan. So this two option is what obviously wrong, because lowest SFC will have a turbofan. So A and B you have option. Now you need to compare ramjet and turbojet. Yes or no? You need to compare ramjet and turbojet. See, this is what ramjet and this is turbojet. Now, this thrust is totally depends on the turbine inlet temperature. Okay, turbine inlet temperature. More turbine inlet temperature, more thrust. Because more turbine inlet temperature means more exit velocity. More exit velocity means more thrust. Just listen carefully, you may understand easily. Okay, thrust will be depending on the amount of the fuel. That is true. And another is what? Like TIT, turbine inlet temperature. That because turbine inlet temperature also depends on the amount of the fuel you are burning in combustion chamber. So you can say easily thrust is what totally depending on the turbine inlet temperature, and turbine inlet temperature will be depending on the amount of fuel you are burning in combustion chamber. Okay. Again, turbine inlet temperature, I will say, will also depend on the compressor ratio, because see, suppose at turbine inlet temperature you want 2000 Kelvin temperature, just simple idea. And for that 2000 Kelvin temperature, one thing you burn only fuel, amount of the fuel, then you will get 2000 Kelvin temperature. Otherwise, you can take help from the compressor also, because what is the work of compressor? To rise the pressure and rise the temperature. So if you are rising more temperature from the compressor, okay, and you are burning less amount of fuel, also okay. Why? Because you are getting same TIT means 2000 Kelvin. If you take compressor help, then you can burn less amount of the fuel in combustion chamber, but you will get same the temperature 2000 Kelvin at turbine inlet. Okay. So the meaning is here in case of turbojet, because you are having uh, compressor. So with the help of compressor also uh, you can raise the pressure and temperature to get the same amount of thrust. And if you are raising pressure and temperature with the help of compressor, so you can burn less amount of fuel in combustion chamber. That will also be okay to get the same amount of thrust. So where m dot f you are using less, that is turbojet. What now? At the same time, we'll talk about ramjet. Check in ramjet any compressor is there? No, nothing. So only and only thrust you are getting because of the whatever depends on the like whatever the amount of fuel you are burning in combustion chamber. There is no compressor and turbine in ramjet. All right, because it is a non-rotatory part based engine. We don't have a compressor turbine. Hope you understood. So more and more fuel you are burning in combustion chamber, more and more m dot f you are using in combustion chamber to get the same amount of thrust. So more m dot f means more SFC, less m dot f means less SFC. Yes or no? So in next will be your turbojet where you will get less SFC, where you will get highest SFC, where you are burning more amount of fuel, that is ramjet. So check, more SFC will be ramjet, hence more amount of the SFC will be ramjet. So this is the maximum and this is the minimum turbofan, and turbojet is what middle. Okay. So if now I will write the SFC, so here m dot f divided by thrust, and thrust is constant. So SFC I will write for first a maximum SFC. You will have a ramjet, then SFC you will have a turbojet, okay, and then you will have SFC for turbofan. This is what, okay, from highest to lowest. But here they are asking lowest to highest. So which one have a lowest SFC? It is nothing but turbofan. I think whatever the explanation I have given, you understood that. Still, if you have any doubt, write comment on comment box. This is the correct answer. Okay. What is the option? What is the option given? Option is option B. Okay. So answer is nothing but option. Hope you understood this. All right, we'll go for next question. This is problem number 29. In a turbojet engine, the compressor outlet temperature increases. Okay, compressor outlet temperature increases with decreasing efficiency of the compressor. Okay, decreasing efficiency of the compressor. If the turbine inlet temperature remains constant with decreasing efficiency of compressor, the thrust specific fuel consumption of the engine. Very nice question. See, so in fact, if you draw the turbojet engine, so check. This is the turbojet engine, right? So I will give the numbering. So this is nothing but A. This is nothing but you say 1. Okay. This is compressor up to here. No? This is 2, and from here to here, this is combustion of chamber 3. This is what turbine 4, and this is exit, which is nothing but uh, exhaust of the nozzle. So based on this, because they are talking about like check what they are saying, the compressor outlet temperature increases with decreasing efficiency of the compressor. So now If the turbine inlet temperature remains constant with decreasing efficiency of compressor, the thrust specific fuel consumption of the engine. So where is the turbine inlet temperature? Check. This is the turbine inlet temperature, means T03. Turbine inlet temperature means T03. It is constant. They are saying it is constant. Listen carefully, okay? And compressor outlet temperature increases with decreasing efficiency of the compressor. Compressor outlet temperature increases. So I will show you the diagram. Compressor outlet temperature means this is the T0. They are saying increasing. All right, listen carefully, you may get your correct answer. Decreasing efficiency. With decreasing efficiency of the compressor, the turbine inlet temperature remains constant. With decreasing efficiency of the compressor, the thrust is specific fuel consumption of the engine. That is the question. Anyway, so now check. They are saying T03 is constant. Overall, T03 is what? Constant. Means whatever the amount of thrust you are getting, that will be constant. You understood or not? Because T03 temperature or whatever the changes are there in compressor doesn't affect on the turbine inlet temperature. Means thrust will be constant in that case. Thrust will be constant. Yes or no? Now, so how to relate that turbine this compressor outlet temperature with the efficiency of the compressor. So first I will write the efficiency of compressor, so it will be more clear to you, because efficiency and compressor temperature we have to relate. Efficiency of compressor. Okay. So this TS plot is more familiar. Okay, this is the PA, or what is the point for the compressor? Check. Compressor 1 and 2. So I must say this is P1 and this is what? P2, pressure, two pressure line. Okay, so this is what 0 1 and this is what 0 2 and this is 0 2 dash. 0 2 dash. Okay, what is the compressor efficiency? It is called isentropic compression, because it is compressor, so obviously it will be rise divided by actual temperature rise. What is the work of the compressor? To rise the enthalpy, or to rise, because enthalpy is rising means temperature is rising. So you can write isentropic enthalpy rise divided by actual enthalpy rise, or you can say isentropic temperature rise divided by actual temperature rise. What is the isentropic temperature rise? T naught 2 dash minus T naught 1. This is your reference temperature, not 1. T naught 2 dash is the isentropic rise of temperature divided by actual rise, T naught 2 minus T naught 1, that is meters. Check here. T naught 2, they are saying T naught 2 is rising. Now you tell me, what happen if T naught 2 is what rising? It means eta C will be decreasing by the formula. Now check the statement. What they have said? They have said compressor outlet temperature increases with decreasing efficiency. That is true. Yes or no? If temperature outlet of the compressor increasing, then efficiency of the compressor will be decreasing. This is true. They have said turbine inlet temperature, or you can say T naught 3 is constant, that next step. So it means thrust is also constant. Yes or no? So what will be the here only I will write what will be the SFC. So SFC is nothing but m dot f divided by thrust. This is the formula. Yes or no? M dot f by T. Thrust is constant because TIT they have clearly mentioned it is constant. Now we'll read the last statement. What they are saying: with decreasing efficiency of compressor, thrust is specific fuel consumption of the engine. If with decreasing efficiency of compressor, if compressor is what decrease efficiency is what decreasing, then what will be the thrust specific fuel consumption of the engine? Okay, simple check. If compressor efficiency is what decreasing, then what will be the SFC? So compressor efficiency is what decreasing means what? T naught 2 is what increasing. In first statement they have said clearly, when outlet temperature of the compressor is what increasing, compressor efficiency decreasing. That is true. Now they are saying if compressor efficiency is what decreasing, then what will be the SFC? And one more word they have said, TIT is what constant. If TIT is what constant, okay, so it means thrust is what constant. So I must say thrust is what constant here. Now, if compressor efficiency is what decreasing, then what is the mean of it? It's mean T naught 2 minus T naught 1. This value is what? Increasing. This value is what increasing. Yes or no? If this value is what increasing, it means eta C is what decreasing. All right. So if it is increasing, then how it can increase? TIT you need to make it constant. Then how this T naught 2 minus T naught 1 will be increasing? Because T naught 2 minus T naught 1 is the actual temperature rise. Okay, actual temperature rise. So that's the reason, because actual temperature is what greater than isentropic temperature rise. Hence your efficiency is what decreasing. All right. So now your compressor is what not so much efficient to raise the temperature so that you can make TIT constant. So now what you need to do? You need to burn more amount of fuel in combustion chamber to make it TIT constant. TIT means turbine inlet temperature. To make it make turbine inlet temperature constant, you need to burn more amount of the fuel. Okay. So if you are burning more amount of the fuel, m dot of you are increasing, it means SFC will be increasing. I hope you understood this. Because compressor efficiency is decreasing means it is not efficient to raise the temperature. Efficiency decreasing means what? It means it is not much more efficient to raise the temperature. So because of the compressor you are not able to raise the temperature, then what is the another way to burn? What another way is to burn more amount of the fuel to make it constant thrust or to make constant turbine inlet temperature. If you are burning more amount of fuel means m dot f you are increasing, so SFC will be increasing. I hope you understood this explanation. Okay. Now decreases, no. Remains unchanged, no. Increases as the compressor needs more work. Why? Because it is not efficient. Its efficiencies were decreasing. If it is, if required uh, more work input from turbine, it means turbine should do more work. How the turbine should do more work, and that temperature also should not decrease. It means you have to burn more amount of fuel so that more work turbine can develop and it can transfer to compressor. That is also correct. that this statement. I mean, if you go through this like needs more work input from turbine, that is also you can understand by this way also. Otherwise what I have explained, like okay, compressor it is not efficient to, because efficiency decreasing, it means it is not efficient to raise the temperature. So what you will do, you will burn more amount of fuel. If you are burning more amount of fuel, so you know SFC is nothing but what, m dot f divided by thrust. So if you are increasing m dot f, so SFC will be increasing. So increases. This is correct. And as the compressor, this is the explanation. Only increases is enough to give the answer for it. No? Because rest here it is decreasing, remains unchanged, it is decreases. Okay. But which one is correct? Option C. So this is also wrong. Option C. So what is your answer? I hope you understood now. Whatever the explanation I have given, I hope you understood, because it's a simple one here. You just analyze the things. Okay, this is like related to optimization of the engines, turbojet engine, turbofan engine, optimization, like how we can increase SFC, how we can decrease SFC, how we can increase thrust, and how we can decrease SFC. Because SFC you don't want more SFC means more fuel you are burning, that you don't want. Yes or no? Less amount of fuel you want to burn, doesn't matter it is airplane or it is your bike or it is your car, you want to burn less amount of the fuel to travel from one location to another location. So SFC should always be less amount. SFC should be very less. Okay, always that will be your like you will try for it to decrease the SFC. Hmm? So I hope you understood this. Now this one is over. Get 2019. This was the solution I have given. All right. So you all liked video and subscribe the channel. Those who are new. So I'm uploading like every 2 3 days. I'm uploading 1 or 2 videos. So you will get notification for the new coming videos. All right. Do hard work. Thank you all. Thank you so much.